Hi, everyone. My name is Dave Kraus. This meeting is being recorded. Today's presentation is going to be presented by Adam Jacoff from NIST. As you all know, I'm the industry member for the FAA safety team. Today, we're going to be doing another presentation promoting safety. It's always important for us to join together and learn more about this industry to try to better ourselves and develop a safety culture. Adam's presentation today is going to cover the standard test methods. He is an employee for, he's a federal employee for an organization called NIST. NIST stands for the National Institute of Standards and Technology. It's a division of the Department of Commerce. Adam's been with NIST for over 33 years. So we're just going to pass the floor over to Adam.
All right. Thank you, Dave. Appreciate that. So as you mentioned, my name is Adam Jacoff, and I'm from the National Institute of Standards and Technology. As part of the Department of Commerce, as a federal laboratory, our mission is essentially to improve commercial competitiveness and facilitate integration of emerging technologies in a variety of key areas. My area is robotics. So I lead the project within NIST that's working on developing the measurement science and standards infrastructure necessary to evaluate robotic systems, be it ground, aquatic, or aerial systems, so that we can start evaluating objectively the capabilities and the remote operator proficiency necessary to be effective. So we disseminate our outcomes to promote innovation, increase competitiveness, improve safety, and that's essentially our goal. And I would say this project is really representative of that mission statement at its core. So in this presentation, I'll be discussing how standard test methods can help enable small unmanned aircraft systems to safely and effectively integrate into our national airspace. And this is really for all users, but I focus mostly on emergency responders because this work is funded by the Department of Homeland Security in large part. And a lot of the early requirements that we got were from a variety of emergency responders, search and rescue, firefighters, public safety. And if these tests answer their missions, I'm pretty sure we're covering the needs of a lot of commercial and even recreational pilots as well. So all these tests are going through FAASTeam International. That's the standards body. NIST does not develop standards. I chair the standards committee. I help shepherd them through the standards process. My job is to sort of do the measurement science work, validate the tests with the variety of folks involved, stakeholders all around. And the FAASTeam committee are the publishing house for the standards, if you think of it that way. And it's the FAASTeam International Standards Committee on Homeland Security Applications Response Robots. So my list of collaborators in this international endeavor is really, really long. I've got a shortened list here. It is just the folks who have been involved from the beginning and kind of stayed involved throughout, but the list is really, really long. This is truly an international effort. We are in many other countries with the exact same tests, validating them to ensure that they work, not just in multiple languages, you can imagine that, not just with different systems, you can imagine that. It's essentially to enable that standard, that international standard, to sit as the central organizing principle, the tangible task in the middle of all of our conversations. So a lot of times it's hard to talk directly to people in wildly different situations, be it emergency responders across the spectrum or international language barriers. But the tangible standard test apparatus and the performance data that comes out of it is really where everyone starts focusing on the same exact details. So that's what got us involved in this game. The problem always has been how do emergency responders and others evaluate their systems to understand whether those systems are capable and reliable enough to perform their jobs. lately, we're talking in the aerial domain about licensing of remote pilots. That is a very good example of where standard test methods can play a pivotal role. So I'm going to kind of emphasize that in this presentation. But you understand that everything I say about evaluating pilots works similarly for evaluating the system itself. The only difference is when I'm evaluating the system, it's in the hands of an expert operator or pilot provided by the manufacturer. So they're expert in quotes, meaning it's the best the system can do. We all get to see how we train up to compare to that. And so NIST is, as the objective sort of arbiter in this process, really ideally positioned to help make this international effort go. And it has been working for now more than a dozen years in a variety of ways, starting with ground robots and aquatic systems. And now we're applying all of our best practices and lessons to the aerial domain. So the outcomes from the project in general are test methods that then go through the standardization process. Those test methods come with apparatuses, performance metrics, data collection tools. And what you're going to see here is kind of the poor man's version of all of that. There's a lot of advanced technologies I could bring to bear on the subject from NIST, but we don't do that. The idea here is that these tests are for everyone else to replicate, and therefore they have to be readily accessible. And then once these objective tests are in the hands of everybody else, researchers, manufacturers, we get to push the state of the science, we get to measure progress, we get to highlight breakthroughs, and the resulting performance data, of course, helps compare systems to specify purchases and ultimately operational pilot proficiency for credentialing. So quick look at the process. It's iterative and ongoing, and we're doing 5 or 10 concurrent tests at a time because they come in suites, but we develop the reproducible apparatuses that are cheap and easy, measure combinations of existing capabilities, whatever's commercially available with the manufacturers, inspire innovation, mostly through competitions, robot competitions, where I inject these tests as challenge tasks. The RoboCup Rescue is a competition I do every year for the last 20 years, but you may have heard of like the DARPA Robotics Challenge or the World Robot Summit is going on now. It's going to culminate in October, if it happens, in Japan. We help guide purchasing and deployment decisions with the objective data that comes out of all those events. And that helps focus training and then identify readiness issues, gaps in the capabilities, either in the commercial systems or in your training. Setting priorities is always a focus because there's so many different systems. I mean, if you're just thinking aerial systems, there's so many different systems, but we're also dealing with ground and aquatic systems. And so I don't draw strong distinctions between the 3 domains because I just this last week saw the first aerial system splash down into the water off Port Hueneme, California, and swim toward one of our underwater tasks, just like it would if it were flying. So, ground robots can fly a little bit if it helps them. Aerial systems can swim a little bit if it helps them. So in general, we're just laying out quantitative measures of performance across all those domains. So we try to find the low-hanging fruit wherever it happens. And we do that through requirements workshops with everybody, validation exercises with users, responders, or any users to validate the tests. The evaluations are kind of manufacturer specific and comprehensive, and those are often attached to procurement decisions. Air Force just did one for $75 million and used our tests, but we've done now $200 million worth of such evaluations to help guide procurements. But what I'm doing really is validating that the test worked for those customers and for those robots. The research competitions I mentioned and the standards committee, of course, is the ultimate dissemination tool for the product, for the end product. And that's how you end up with 50 tests across 3 domains in subsuites for mobility or dexterity or endurance or sensors. You'll see a lot of crossover from ground to aerial. And when we talk about the aerial stuff in specific, I'll mention how the aerial stuff became easy to do from all of the existing ground tests. The only trick was knowing where the drone was at any given time, what the range to target was. But all of our tests end up being this notion of cheap and easy to replicate, simple instructions. They're your tests. Go, use them to your best effect. So in case you think we're just off on the wrong tangent here, that this is just never going to work. Project's gotten some pretty high level recognition lately. It kind of started from responder organizations that were, doing guided procurements and training, and bubbled up through the federal agencies that we were helping, and turned into an FAASTeam award of merit, which is their highest honor. So for cranking out the original standards for the ground systems, that bubbled up to the Secretary of Commerce and Excellence in Innovation Award and the Gold Medal Award last year. And that turned into the Presidential Gears of Government Award. So all of this is essentially for the ground robot suite of tests, which is, if you think about it, just a paradigm, an approach that everything I just said resonates with people. It gets manufacturers talking past their marketing. It gets responders and others understanding the breadth of the emerging capabilities and which ones might help them the most. And so this is now turned into the Service to America Medal. We're finalists for the Safety, Security, and International Affairs. It's just settled in October, I believe. But the idea is that the model is sound, and now we are turning this toward aerial systems. And so we spent a large part of the last couple or few years focused on these vertical takeoff and landing systems. What I will say is any vertical takeoff and landing system with an onboard camera, remote pilot display is in the game. We're not as focused on, things like drone racer type deals. And we're not as focused on fully autonomous systems, although I'm in the intelligent systems division. I believe in my bones that what makes these systems good and what makes you look good flying them is intelligent controls and autonomous behaviors. So totally moving in that direction. As a matter of fact, that's why I set up the whole project to begin with, was to settle the bets in the research community about what was working in terms of autonomy and needing side-by-side measures. So the aerial market is just booming, and they have needed no encouragement from us or standard test methods to want to innovate. They're doing it because of the market share, which is great. So we have sort of flipped the paradigm with the aerial systems, and the aerial systems are the reason why people are replicating our tests for aerial systems is mainly for training and evaluation of pilot proficiency and to compare people operating systems as opposed to the systems themselves. We're still doing it, and there'll always be procurement support, but these systems have been so inexpensive that individual agencies have been just buying them. So I want to mention that although I'm talking about vertical takeoff and landing kind of exclusively here, most of these tests were designed for forward flying aircraft. So they work for forward flying aircraft. If you just spread the baseline out, the spacing as we call it, which we'll get into, if you spread it out to be the orbit radius of whatever forward flying aircraft and altitude, whatever forward flying aircraft you're flying. But I'm going to focus on VTOL because I wanted to get a complete arc of standards all the way through from procurement, through training, through credentialing. And I think we're there now as an example. And then we can replicate that example for forward flying and faster or bigger systems. So how do we measure systems one example is open area identifications. Call this a sort of a group of missions that are popular, let's just say, or essential. Whether it's a wide area search or more urban or more specific to objects, train crash, multiple train derailment, or individual rail car or tanker truck. The missions break down into, in our vernacular, open areas or more obstructed areas where there's some danger and some proximity you need to deal with, or indoor confined flight. So starting first with the open area identifications, where everyone should really start their process no matter what. Here you see like a sort of an urban area, a mount site. You see white buckets in sun, and you see shade out in the open versus up against walls and such, occlusions. The black buckets here in the ravine, they tend to hide a little bit better in the shadows. And you see in the bottom like a structure inspection. These are all using these directed buckets as recessed targets, forcing you, the pilot and drone, to get into that cylinder and look toward that directed target. So this is an omnidirectional target. If you're looking at the omni stands on the lower frame, it's dual buckets, 2 buckets verging to a point. The idea here is that with the notion of single buckets and targets that are recessed, and certain things on those targets, like the inscribed ring, be it colored or not, a visual acuity target with different levels of resolution, that is all you need to get in this game and start measuring your systems and yourselves. The inscribed ring is an alignment cue, tells you you're there, and the visual acuity target in the middle tells you you know how to operate your system to some effect, overlaying some sort of workload. And you can see how instrumenting a scenario, your scenario, with 100 points worth of bucket targets can be a repeatable and ongoing scenario at your facility. It's not so comparable to other people's facilities, except for the fact that they have 100 points in their scenario as well. But at your scenario, in your time of year, it presuming foliage is part of it, you're very directly comparable. So you can run people through and get a track record and start monitoring your progress. So open identifications are one level of, let's just say, difficulty in flying. It leads you to more close proximity identifications. You know, even if you start open area, sometimes you just need more information because you don't have the optics to do it from a safe hover altitude. We don't typically specify much in the scenarios except for the target layout positions. So in this case, all of these targets are laid out according to a recipe, and the recipe says there will be an omni on top, and you should strike an orbit around just to see if there were 10 tanker cars or 10 vehicles in Times Square. Maybe you don't know which one you're supposed to look at closely. So you're supposed to do a quick reconnaissance. And then there's always 5 targets on the A side and 5 targets on the B side, C side, and D side. So there's always 20 targets. Those 20 targets are worth 5 points for maneuvering, or they're worth 5 points for each incrementally small visual acuity target. So there's 100 points according to a recipe. Now, we're not telling you what's important in your scenario. You have to define that. But if there's a hazmat placard to read, you probably put a sticker near it. If there's a license plate to read, a VIN number, an interior object on the seat, you probably put a sticker next to it. Also note that these stickers work in thermal as well. So, you know, in general, when you're looking at these scenarios, you need to be thinking, what does it mean to identify a vehicle, an object of interest, or a potential hazard? What does it even mean? Your ability to discern details like just colors, motion, thermal, Very good place to start quantifying your performance. That's what we do. That's what this does. In your hands, it quantifies your own performance in your scenarios. And the thermal targets light up because of the sun, the black on white, but in case you're doing night ops or indoor, you add hand warmers behind a baffle or heating pads behind a baffle, and you get the same thermal targets. Okay, so that's sort of an intro to why we're doing buckets. Buckets are there because they're cheap and easy. The stickers are downloadable and printable, so everyone can get on their measuring stick very quickly, very cheaply. And then there are certain tricks for laying out the scenarios so that you're deconflicting airspace if you have more than one drone flying at a time. And there's some best practices involved, but it's really pretty loose at this end of the process. The scenarios are yours. Instrument them using the buckets, and you will have a quantitative result. Oh, I got a couple more here. These are the dual bucket alignments, close proximity inspections. So now we're expecting you to fly within close proximity. You're going to align with one bucket, the perpendicular bucket. You're going to know it's always safe to fly in on that vector, because whoever laid out the scenario laid it out that way. That's one of those best practices. Trust the buckets. The buckets are not there to lead you into harm. They're there to provide you a safe position close to the object of interest where you can relax for a minute. I mean, not totally relax, but get into a position where you know visibly, because two buckets are aligned, that you are safe because you built the apparatus and you know it puts you 6 to 10 feet away from that apparatus. So you are safe. Now work your system. Zoom, contrast control, focus, capture images, look at the object behind the buckets. They're always put in a place where you ought to be looking anyway. Maybe there's a thermal target inside, maybe there's an actual person, mannequin, whatever. You're in charge of laying out all the operationally significant things to find. All we're doing is overlaying a quantitative version of that that's practicable and repeatable. So, you know, what I would say is, until you're scoring of a certain level in the buckets, you probably don't need to hide much in that rubble pile, because you're just not close enough with your system to discern details or whatever. There's a threshold of performance that's measurable that leads you toward a complete training day and a real readiness assessment. That all just happened last week. I couldn't help but put them in. That's the Civil Air Patrol did a 1-week training on the basic course, which is what I'm going to get into. And then this is the more advanced flying course. They did a 2nd week. Okay, so the first step toward comparing system capabilities or credentialing remote pilots is to get everyone onto that same measuring stick. And that's where standard test methods play a key role. They help manufacturers and users objectively evaluate system capabilities. They help align those capabilities with mission requirements. They just provide a reproducible way to train and measure your capability or your proficiency over time. And of course, this can help public safety, industrial, commercial, even recreational pilots. There's some talk on making some drone parks out of these things, where anyone can go in there and measure themselves, much like you do on a Frisbee golf course or a regular golf course, you know, making a sport out of it almost. So of course, integrating these standard pilot proficiency tests into credentialing programs in general, we expect we can help enhance the safety of nearby ground personnel, reduce the risk to manned aircraft in the area. You know, for all the obvious reasons, some level of standard testing is just essential as these drones are integrated into our national airspace. So the open test lane, it's called open because there's no obstructions to worry about, is the most basic lane. It uses the Omni bucket stands to define a series of altitudes, positions, and orientations where the drone can see into one or more buckets simultaneously. It's scalable, so it can accommodate various sizes of aircraft flying indoors or outdoors. As a matter of fact, this lane fits perfectly in a basketball court or a tennis court. When you adjust the spacing between the buckets to be 10 feet, which is equal to a 10-foot altitude for a basic proficiency course. So when you're looking at two buckets simultaneously, it means that you're in a really relatively precise and very repeatable position, orientation, and altitude. And that's the entire game right there. You're moving constantly between very well-defined positions, orientations, and altitudes, no matter what the scale of the lane, which means no matter the altitude of the task. So there are no obstructions. So this is where everyone ought to start. As a basic pilot, this is where we would advocate you begin your practice with beyond visual line of sight or in the dark, or both at the same time in some indoor basketball court with the lights out. You don't even need to be in the national airspace when you're experimenting with these various configurations or settings. So keep in mind, of course, that these lanes can be used to evaluate sensors, of course, endurance, package delivery, and a lot of other essential capabilities, and we have tests for that. But this presentation, I'm going to focus on maneuvering and payload functionality tests specifically. These are the tests that evaluate the pilot skills. That's why these tests are being replicated at various organizations around the world. This is really what's making these tests pop right now. I think this is where everyone needs to understand the value first. So in general, the open test lane is designed to set up quickly and stow easily. This is as a result of, in my field behind, my robotics test facility at NIST, they're out all year long, all the time, lane. And we're pretty much have an open door policy when it's non-COVID. So I never expect to bring mine in. However, I understand that a lot of people do need to fly for 2 hours and then bring them in and stow them for 2 weeks. And that's fine. So that's why the trend towards smaller and more, inexpensive, easy, and stowable, even transportable. There are some people that transport these things around the state as part of their credentialing process. So suffice to say, cheap, easy. So the white buckets, Omni bucket stands are Omni bucket stands. They're all laid out the same way. They all have the number on top, and they have the ABCD around the perimeter going clockwise, as if firefighters, that's how fire and police kind of identify buildings. The A is the front. The A is always facing the launch land platform. White buckets tend to be in the standard tests. Black buckets tend to be in the scenarios. And when we do the black buckets, we invert the coloring of the sticker target so that it's predominantly black. There are always two ways to conduct every test. There's a basic maneuvering way, and then there's a payload functionality way. And they're related, but basic maneuvering is a subset, and it's where everyone starts. Basic maneuvering in green requires the aircraft to pause long enough to align with and capture an image of each bucket. That's the alignment task. So it's move, capture an image, move, capture an image, move, capture an image. And you're graded on those images. Your score is done after the fact, after the trial, based on those images. Because if you couldn't hold position long enough to snap an image, it's an indication that you're loose in your controls. It's probably a system problem more than a proficiency problem, but who knows? Bottom line is you need to align your expectations to that system's capability, and doing that task 20 times gives you the statistical significance to understand how stable that platform is. Okay, so basic maneuvering is a no zoom image while in that cylinder where you're seeing a completely inscribed green ring. If the green ring is broken, you get lesser points. So 5 points for a full ring, 1 point for a broken ring, and a couple of tests have accuracy and landing included in them as well. Accuracy meaning within a radius of 1 foot from center. Payload functionality, same idea. You still need to align with all the buckets. You capture the image as if you're aligned, and then you work your interface and you start reading into the visual acuity chart. So you start calling out, like we're looking at here, in the circle, left, lower left, upper left, and I can't see, maybe up. So I'm seeing 4 deep of 5, not so bad. Smallest one is about millimeter resolution. This is an indication of your acuity from that standoff position. And the standoff position is known because you're aligned with 2 buckets. Taking an image at the high zoom or max zoom gives you an understanding of how hard it is to capture the details in your zoom camera, given the stability of your aircraft, its ability to focus, the contrast. It becomes a practical level of zooming where you say, I wish I could get the last 2. I think I have enough zoom to get the last 2, but I can't practically do it because I can't keep my gaze on the center of that target long enough to snap a picture. And that's very informative. Okay, so to give you an idea what the first 2 tests look like. These tests called position and traverse are essentially what we're proposing as a Part 107 accompaniment. This could be the basic skills test that goes with the written exam. These fly-throughs kind of show the nature of the test. One is positions, you stay on the center line and you move position to position, forward, back, up, down, rotating and taking your pictures. Traverse, you're working around the object of interest, which in this case could be like a woods line or a bus or a vehicle or other. So you're flying sideways. Both of these have landing components to them. So the total point system comes out to 20 points each, or totals 100 points actually each, 20 different alignments and 10 minutes. And so if the 107 skills test takes 10 minutes and can be purchased for $100 in apparatus and can be disseminated quite widely and compared very directly, are we not on the right track for something that could be ubiquitous? Note also, one of the values of standard test methods is the fact that they're so well defined that they work really well in simulation. Simulations flying on the left-hand side here looks very similar, flies very similar. You can introduce perturbations in virtual worlds. And actually there are a couple of hyper-realistic simulations now that we're working with to get our tests implemented in, hyper-realistic like video games. And there's a real need for simulations to add stick time at very little cost, very little danger. There's one thing about just being able to do 30 minutes of stick time every other day, as opposed to having a training day every 2 weeks in terms of gaining muscle memory on your controller. Simulations can really help with that. But beyond that, experimenting with issues in simulation, issues that you hope never happen in real life, and certainly don't want to train to because of the fear of loss of the aircraft or the runaway of the aircraft. For example, a lost comms behavior and a controlled shutdown under duress can be injected into the middle of these sort of simulated tests. So anyway, simulations are coming, and we're injecting the standard test methods into those situations, same as we are into physical validation exercises. So here's a offboard view of that same first test, position test. It just goes through and fills in the form as it's flying. You launch to over bucket stand 1. When you're looking at the form, there's an instruction that says hover at altitude S over stand 1. That works in Japanese and in German to get people to the right place. You circle the bucket number that you're seeing when you align with it. And you check it afterward with the imagery. If you're working the payload functionality blue section of the form, when you see the arrows, what that is means they're zooming in best they can. And they're only seeing 2 deep, because the system just only has a 6x zoom or something like that. Okay, there's nothing wrong with that. That's fine. That system only does 2 deep. You take it to 2 deep and you are using that system to its maximum extent. When you go to the higher altitude and you miss one, whether it's your fault or the system's fault, it doesn't matter so much as long as you're always comparing the same system across multiple pilots. So you're always safe, even if your system is limited, that if you're running the same system in the same test apparatus, your results are directly comparable. They're less comparable when you compare across systems. But if you see some other system consistently scoring higher, that's an indication that maybe it's time for you to upgrade. And the data works as a sole source justification if you tie that upgrade and the statistically significant data to your need, which is your ConOps. Okay, so position test, we mentioned it's down the center line. All these tests are sort of complementary. There's 5 total. The traverse test, as we mentioned, goes around the perimeter, flying sideways, both directions. The orbit test is not auto orbit capable because it's typically too low and small, but I'm all for auto orbits. And then when this lane extends out to an operationally significant size, auto orbits are a very good thing to practice using the same procedure, going both ways, left and right, to identify all sides of the object. The inspect test is more of a free flight. You go wherever you need to inspect every operationally significant package. In this case, it's an Omni stand. You start on top, then you do A, B, C, D, and you do clockwise, counterclockwise, alternately. And then you do the recon test, which is more a fly straight and level at some speed that is sustainably over the center line. It's not your max speed if you can't stay over the center line. It's about being efficient in your accelerations without blending axes and in your decelerations to enter into a stable hover over the object downrange. And then you have these 3 bucket stands near the landing that have images that just pop as you fly over them. It's like landing on an aircraft carrier. If you see the full ring as you're flying by at top speed, you're over the center line. There's also a center line to see in the middle of your view. This test is basically the fastest you go in all of the open lane tests. That's why we put it last. And all 5 together, remember, it's a suite, complementary. You build the apparatus once and you go through all 5 tests. That makes for a comprehensive evaluation of your proficiency or your system's capability. If you're doing the maneuvering tests, the tests are 5 minutes long each, so you can go through in 25 minutes of flight time. If you're doing the payload functionality tests, the tests are 10 minutes long, so you go through in 50 minutes of flight time. So this is why we can see these tests being injected into the start of every training day, so that you have a body of data over time and you can see what your averages are over time. And we'll talk about how important that is a bit later. So tracking scores. There are books of forms available online. You can download. The simplest forms are just trifolds. That's a good place to start. but tracking your scores over time is kind of the secret here. Nothing done once indicates anything. Even at an evaluation with someone looking over your shoulder, that's a lucky day or an unlucky day if you're flying for 10 minutes proctored. The key here is to establish a trend, and the trend should be flat. If it's still increasing, it means you're still learning either your system or the test. So when it's flat and it happens similarly 5 times, plus or minus, that's a very good indication of your proficiency. So the way we talk about the metrics that you can compare are completeness first. That's the primary metric. If you're not finishing tests without making a mistake, you don't need to keep score. You certainly don't need to keep time. The time limits are there to stop the bleeding early in your process. It's to make sure you understand you have a problem with one of those tests, but move on, because there's 5 tests and you need to understand all of your skills and which ones to focus more on and less. Which are your strong points? Where are your weaknesses? So completeness is first. You got to get through all 20 poses without flying away, certainly never causing a safety incident. You know, these are the kind of faults that end a trial. So completeness means going through the prescribed 20 in a safe manner and in a timely manner. If you're doing both of those things, then it's time to start keeping score. Keeping score is the shorthand for, of course, I completed it. And I had no faults. And this is how I did. I had a couple of mistakes. I had a couple of lags on my images, so I didn't get full credit. You know, people can set their own thresholds of what means pass or failure. These tests don't say anything about pass and fail. These are standard test methods. They only tell you how to evaluate yourself and compare yourself. It's up to each individual organization to set their own thresholds. So score is the threshold you would begin to set, and perfect scores are not out of the question. And a lot of people mandate perfect scores. A lot of organizations, responder organizations in particular, want to mandate perfect scores because they're achievable in a timely way. The time limits are ample. They're not there to make it a race. But if you're perfect and if you're complete in your trial and you're perfect in your score, then maybe it's time to put a clock on and see where the efficiencies are. So 2 pilots that are both scoring 100, you can't tell the difference, except that one did it in 4 minutes and one did it in 6 minutes. Everyone will want to watch what that 4-minute time pilot does. Maybe there's some secrets that you haven't quite learned about what to look at when, how to hold your hands. There are efficiencies to be earned. And the best lesson is from someone who scored better than you. So football field layouts are, you know, just one of our favorites for concurrent training, but the notion is the same if you're in a parking lot or a field. Concurrent lanes, because the lanes are cheap, make sure that everyone during that training day are active. The one thing I kind of can't abide is when people are all standing around, or when training requires too much creativity and so people don't know what to do. In this case, it's pretty well prescribed. This is like circuit training. This is a concurrent evaluation with one knowledgeable proctor on the field, a trainer, who sets it all up and calibrates it and collects the data at the end, the images. And this is a credentialing event. And the key is the ratio of knowledgeable proctors to pilots. And we break the pilots up into teams so they can support each other and attest to each other's scores. And then the instructor or the proctor is attested to the whole field of scores. So we'll talk a little bit more about that when we get to credentialing. But just understand that once you lay out this lane, there's a lot of other things you can do with it as well. So obviously there's different altitudes already prescribed. You didn't even have to change the spacing, and you have up to 7 times that spacing in orbits already designated by looking down and forward into 2 buckets. So if you have a new optical capability, you just want to see how it compares to the old optical capability, take it up to the known altitude, put your targets down, at the center of the orbit and see what you see. So that's the standard open lane. Standard open lane comes with some operationally significant scenarios that are of like kind. So an open test lane comes with open scenarios. Open scenarios imply you never really need to come down below your safe altitude. That's just what open means to us. You run through your tests in a strict way, you get your scores, you graduate out of those scores, and you start applying those same learned habits, muscle memory, modes of operation, and you apply them directly into your wide area search or your vehicle inspection or identification, really, from high hovers, or your exterior building search from high hovers. The open test lane comes with open scenarios. And when evaluating yourself, some blend is very appropriate. You get scores out of both. The standard test lane scores are directly comparable no matter where or when those trials happened. The scenario scores are a little more your own, and they're comparable within your facility, and probably over time. And some blend between those is where you want to start thinking about setting your threshold for operation. So there are other standards committees in F-38, for example, FAASTeam F-38, who have defined words like proficient and competent and partially proficient and limited, and they have notions there for instructors and trainers to try to calibrate with each other. What we do is then add the notion of quantitative measures to map onto that. And except for the part where this says 80 to 100 and 60 to 79%, those are fictional. Those are notional. They're color coded. They have icons. This was probably ski season when I made this. And so I adopted ski iconography. You need to decide what numbers go with which level of proficiency. And you need to decide which level of proficiency is required for the operation you are about to undertake, given the weather, given the environment, given the difficulty of the task itself. These are all your decisions. You're just choosing from quantitative data to help make those decisions. And of course, setting your minimum thresholds or pass-fail should not be just willy-nilly. I mean, the idea is to have a body of training data behind you so that you have the notion of averages, and you can look at more regional and national averages to compare your whole roster. You can know the people to the right hand of this chart are not ready for a difficult mission if they're ready to fly at all operationally. And the people to the left are the ones you want when the suspicious package is on the mayor's front steps. It's all a spectrum of performance, but because it was quantified, it now gives you a lot of knowledge to start making real deployment decisions or upgrade decisions. So when we're talking about credentialing, and this is where we are now, the tests are starting to be used in this way. Credentialing can be thought of as a daylight line of sight, basic kind of, shown in green here, a basic kind of Part 107 accompaniment, just the basic skills test. You are not a hazard to yourself and the nearest non-participants. Good threshold to get across first. Whether that happens in simulation at Part 107 test time, in the same facility, indoors, non-flying, not physically, that's an option. If we're talking about going to physical flights and it happens regionally by some credential proctors, that's what's ramping up right now as a service through the Airborne Public Safety Association and drone responders. But what we're looking at is, where can this go? So the notion of BV loss, whether it's to prove that to yourself that you're safe, or whether it's to get a waiver, or whether it's to help the FAA to understand that certain thresholds apply. Same can be said for night ops. We have stories for how to conduct all these things that are not different than everything I just showed you. The idea of a BB loss is you turn your back to the test lane. Literally, you're still right there, but you turned your back. You get a visual observer to help you, keep you safe, stay legal, do it indoors even. And the same with night ops. You do it in a basketball court and you turn the lights out. Those are night ops tests. It's the same test lane, whether the buckets are lit or whether you have onboard illumination. You do it the way you plan to do it operationally. You know, sometimes there's lighting in nature. You know, things go down in parking lots at night where they're pretty well lit. And other things are absolutely not, and you need to bring your own lighting with you. These are the things you can practice in a controlled environment, but just by turning the lights out. So whatever the thresholds might be, the idea of the test is the same. The standard test has not changed one bit. It's only a setting for the pilot or the environment that changes. So as I mentioned, this is kind of underway. Proctors are being credentialed and pilots as well through the Airborne Public Safety Association. They've stood up a series of courses monthly through next year, I believe, or deep into next year. We've been through, there's one going on literally right now, August 12th, 14th in Fairfax. So there are 100+ proctors. Proctors take the 3D course, graduate from it, know how to build the apparatuses when they go home. They know how to run their own pilots through. They are now deputized to do that for APSA, and then the resulting pilot credential can follow. And that's a separate fee through APSA. So 100+ proctors might go home and credential 5 pilots in their home organization or 20 pilots. We don't know. But the idea is it's going to get geometrically bigger from here. A lot of the emerging use cases were also validation exercises. That's kind of how we populated these folks. You know, they signed up early, they raised their hand, they said they're interested. We go out, we help them ensure that they're building the apparatuses right, help them conduct some field exercises. I'm validating that the test is working for them. I'm getting feedback, I'm refining. They're getting the measurement science in a package, like an early Christmas gift, and they're using it to their best effect. So some of the stories, you know, of course, I'm all for helping all the feds. And I get, you know, sponsored by a lot of these feds to do that. But the Civil Air Patrol is one to make note of. As I mentioned, we just did their first. Well, they have training going on. They've always had credentialing going on, and they have 52 wings. I think I have a slide next. 52 wings, 1,200 pilots. They've always had certifications, and their check rides with the wing commander, I guess, or the wing commander's designate. All we're adding to that is the notion of the quantitative scores that can be tracked over time and compared across wings. So ultimately, this will be a very distributed model of the open test lane, built individually by the different wings. They come together for training. So they're learning about new systems that they're buying, and they're learning about how to run and fabricate the standard test methods at the same time. So that's when they come together. But generally speaking, this is a disseminated model across 52 wings that shows that this idea can scale. And there was an article that went out to all their 60,000 subscribers. And there's been a series of these articles that have gone out to user magazines over the last, several months throughout the COVID era. That's kind of what we were doing. So just kind of wrapping up here, the 3 different test lanes. I've really talked in depth about the open test lane. I showed you some scenarios of the obstructed test lane where you're in close proximity. That's what's in the middle in orange. The confined test lane is indoors, by definition, GPS denied and dark, but it's exactly the same tests as the obstructed lane. They're just scaled to half size. So now the standoffs are 1 meter or 3 feet. The environment is a shipping container. So there's a roof right there. There's a wall behind you all the time. It is a confined test lane. It's not for everybody. It's not for every aircraft. All these 3 test lanes are for different people, different missions, different aircraft. You decide. Of course, there's cross representation if you're interested, but just keep in mind, we keep them separate. We don't call it basic and advanced, or I at least try not to. I call it open, obstructed, and confined. An example of the obstructed apparatus here with the bucket pairs colored white and black. This is kind of a new, so these are less mature. The obstructed lane are less mature than the open test lane. The open test lane is going through the standards process like now, essentially. We validated that enough. The obstructed test lane will be right behind it because it has matured very quickly based on all the lessons learned in the open test lane. So here the buckets are dithered in pairs, white and black, and that forces the pilot to work the contrast control just a little harder to deal with that range. And I showed you how those get implemented in scenarios. Similarly, once they get in scenarios, they're typically all black. But this is an obstructed lane notion. And the rest are yours to do with what you want. So we help people. We go to validation exercises where they're doing procurements or they want to inject standards into their training. And again, I'm just validating new tests and I'm disseminating the results of the tests that exist. And Montgomery County, Maryland, my local police was the first place I could go to in the COVID era. So we set them up. The ski and trap range becomes the standard open test facility lane with a sensor lane in the middle, high hover. And the shoot house becomes the confined space scenario. And they bring in their armor personnel carrier as the attenuation chamber to do our radio comms tests. And we set up the hose and sprinkler heads with diverging buckets to do our rain tolerance tests. So this is pretty much what we're doing at every one of our field exercises. We're pushing on 20 tests all at the same time, 20 aerial tests all at the same time. And the ones that pop first are the ones that have gotten the most exercise because the most aircraft could take part. So, and just a notion of how the color coding goes from, exterior high hover kind of concepts through to interior room-to-room searches, stairwells, inside of buses and trains and planes. So I showed the videos for this, but the idea is that scenarios, although I started with them, scenarios are really the end of the story. The scenarios are where we let it go. This is what you should be doing to evaluate your readiness before going on missions. I would say the paradigm that's sort of popping up is that when we set up, for example, Montgomery County, Maryland, as a training facility with instrumented scenarios, people from Fairfax, Virginia can come over to Maryland where they don't really know the woods layout in Maryland. They don't know the mini mount site or the vehicle or the shoot house configuration. So your home scenario is good for practice and refinement and tracking scores and working out issues. Going to somebody else's scenario is an excellent evaluation of those skills because it's not as well known. Now, it's not like the buckets are hiding from anybody, but you'd be surprised just how much the buckets are hiding from everybody when it's in somebody else's world that you don't know. So these large rodeos that we go to, or the summits, like we just did one in Texas, really excellent circuit training opportunities where all we're doing is validating the next test method for the standards process. So everyone is taking part, whether they know it or not, in the standards development process. So how do you get involved? Well, you can always go to our website, the NIST website. My project website is at robottestmethods.nist.gov. Robot test methods, all one word. This QR code will get you there too. It's pretty much in the header of everything. I'm pretty sure you'll get the PDF of this. So there are pointers, there are hyperlinks in there. But if you take a picture of this QR code, it will get you there. You can go to the APSA courses that are monthly through next year. These are the scheduled ones that I grabbed off their website just 20 minutes ago. And this QR code will get you to their website. If you happen to be at AVSI in Atlanta next week, we're going to be flying on Monday in the Mercedes-Benz Stadium, the Falcons Stadium, NFL Stadium. You know, we're going to do the football field layout as typical. We're going to try to do as much of the scenario that go with the football field layout as we can. But in any case, it will be a concurrent lane event with proctors on every lane. APSA proctors already graduated on every lane, taking Atlanta Fire and Atlanta Police and anyone else who wants to bring a drone and spend 10 minutes through the basic proficiency evaluation so that they can be APSA certified as basically proficient pilots if they want, or just get familiar with the latest tests, practice, practice, practice. You know, we don't care. We're not pushing anything when we're doing these things. This is all familiarization, but for us and for trainers who are working, not us, but trainers who are actually working those kind of events, they're figuring out how to run such a concurrent evaluation and a credentialing process. And they're going home with the best practices from these kind of events. So Dave, if that's not enough, I got more, but you know, it's all of a different flavor. So I think we'll save it for the next installment.
Thank you, Adam. I appreciate your time and the sharing of information. You know, what Adam shared with the group is, you know, the capabilities of NIST, how his organization evaluates robots, ground rovers, surface floating, submersibles, and aerial platforms. How he teams with organizations that are willing to assume burden of responsibility and liability for credentialing. Thousands of organizations around the world are adopting this program. Airborne Public Safety Association, FAASTeam International, National Fire Protection Association, Civil Air Patrol, Canadian Transport Aviation Authority, various fire departments, police departments, colleges, lower schools, and everybody else. But this is a tool to measure yourself. This is not a replacement for anything that the FAA may be asking us to do. As a community, we have a duty to recognize the authority that governs us. In the United States, as it relates to the aviation, it is the Federal Aviation Administration. But Adam just shared with us something that is a supplement and can help us show that we are proficient and that we are trying to grow this industry together. So while we await what we need to do moving forward, this is a way of you measuring yourselves. Hopefully what Adam shared is something that you can take home with you and a way to make sure that you become a better and safer pilot. So with that, we're going to open it up a little bit for any questions. It'd be a little bit easier if you just hand raise as far as, you know, just start blurting out, and I'll call on you and I'll just unmute your system. Anyone doing anything? So we'll jump in. Mark Kaler, I see you're already unmuted. How are you doing today?
Sir, how long is the credentialing process for proctors?
The credentialing process through APSA is a 3-day course, 24 hours of course over 3 days, where you learn literally how to fabricate the apparatuses, sticker them up, lay them out, you know, calibrate, and conduct trials. And you conduct trials with the other people in the course. You know, there's always 30 or more people in the course. And then on the 3rd day, they open it up to walk-ins, like we did it in Texas. And there was, you know, I don't know, 50 or 100 walk-ins from a conference. That was good fodder for you to practice proctoring. So it's a 3-day, you know, semi-intensive, open lane and scenario only focus to get APSA certified.
Thank you. What is a good UAV model for practicing in regards to capability, durability, and price?
I think that's a little bit offline
Specific.
or out of scope out of this presentation. I'll tell you what, I'll actually drop my email in the chat session right now. And if you would like to message me on that direction, I'll be happy to help you out.
Great, thank you. It's a great
Yep.
presentation.
Thank you.
Yeah, so just to understand that, as NIST, I don't endorse any products. If you happen to see products in my presentation, it's because they were at an event and they were helping with the validation process. And, I don't even really say what's good or bad. What my game is to try to help people align their expectations with what they have or what they want to get. But that said, you have a very specific question that makes a lot of sense. And what I can tell you is I tend to show video that is good and not bad because I don't want to show failure. I don't want to embarrass any particular systems, but you know it when you see it. And you don't have to line up to a bucket very long to know whether you have a system that's going to make you look like a hero or a goat. So that said, if you just literally go through a demonstration of it or watch somebody else try it with a certain system, you'll have a pretty good indication whether you're going to be able to pick up that system as well.
So allow me to kind of translate what I think Adam is indirectly saying. When it comes time for you to evaluate a product, you could always put that product up and through the NIST course and see if it's working the way that you want it to. Whether you challenge a dealer, whether you challenge a manufacturer, whether you do something off on your own. This program is essentially providing you with a yardstick to measure something equally across the board.
Yes, thank you. For the simulator that you demonstrated that had the NIST course built in there, was there partnership with the sim construction, or was that something that the simulator designer just took upon themselves?
So it works well. It doesn't. No, I mean, I don't know of anyone that's done it without us. But what we've done is we've made our 3D models, our object models, available to anyone who wants to put them into their simulator. So we don't get too involved in their half of it, but they take our actual models and insert them. So that's available. There are instructions on our G drive. I can put the G drive in the chat. There's instructions for how to inject our test lanes into that free simulator if you're interested, just like our fabrication guide.
Yes, that'd be great.
That sound good? Okay.
Awesome. See a familiar name there, Dave. How you making out?
Hey, Dave, how are you?
Pretty
And
good,
Adam,
my friend.
You guys did a great job today. So I got my pom-poms out for both of you. I wanted to bring up the statement or the point that John Meehan had put in the chat room, talking about pilot behavior as we're working on NIST. And to emphasize what Adam had put out, that, this is a tool for us to tailor our programs to develop those pilot proficiencies. But as John was mentioning, this is a great start to do exactly what's happening on the crewed aircraft manned aviation side, that when you have standardized test methods and we can demonstrate safe pilot behavior, that equates to future discussions with insurance companies and premiums. So I'd like to recommend in the future conversation that we look at that big picture on developing the professional drone pilot and how we can help the industry along using this approach and other education to get a better position with making it easier for pilots and insurance.
Absolutely. I think, you and I both are, cut from the same cloth as far as our beliefs here. A lot of us are. We just want these guys to be safe and we want this industry to grow the right way. So, anything that we can add, to another level of protection to grow this industry is the direction we need to go to. So I apologize. I didn't actually see John's comment, and I scrolled through and see it right now. So thank you, John, for your feedback. We appreciate it. And Dave, thanks for pointing that out too. And hopefully we'll see you down in Atlanta.
I'd love to be there, but I'll be on the West Coast cheering you guys on. So good luck out there.
Thank you. All right, Tony, you're up next.
All right, thanks. My question is more of I'm a aircraft provider. We specialize in unmanned airships and blimps. We just won a U.S. Air Force STTR contract to build a 35-foot demonstrator.
That's
and
awesome.
This sounds like something we would love to go through because we're higher altitude, but we're using a lot higher res cameras with a lot better zoom capability.
So we have high hover stability tests that I didn't talk about. That are
where the half of this contract is making is the autonomous attempts, making it autonomous. So this could be very useful. And as far as the use case for search and rescue and all that, but I like the way that this validates and actually gives us some feedback numbers on how we're doing, because we're supposed to demo this for the CBP, Border Patrol, and the Coast Guard. And it'd be nice that if we ran through this course first to tell them that, we validated something.
So like, I mean, if you're touching upon an awesome point, I mean, this is, to me, I think manufacturers should should measure against this as well. Every single person, whether you're an operator or you're a manufacturer, if we all measure against the same yardstick, there's no question. Every single one of us probably owns a tape measure in our house or a ruler. We're familiar with standard measurements, and all we're doing here, thanks to NIST, is applying that same equivalent to robots. So I'm sure Adam's got a whole bunch of ideas, and he'll probably reach out to you. Can you drop your contact information in the chat room for us?
I did. It's TonyWhite@galaxyus.com. I put add me, please. I was trying to get on your list, so I'm in the chat. But definitely, I don't know if we have to schedule one of these events or something. We have a little bit of budget to do some other demos outside of that, but because we're in Central, we're in Texas, and we're making this whole thing mobile, so we should be able to easily pick up stakes and go where you guys are.
Awesome.
So this is the 300-foot high hover test, and when I am working with various organizations, some spooky, some not, they're invariably integrating our targets, visual, thermal, motion, color, everything, into their scenarios. In this case, this suspicious vehicle is driving by all of the targets that we place there at known positions to be seen from 300 feet. So they're at 300 foot, 600 foot, and 900 foot away.
So Adam, I'm not sure if you're meaning to share your screen, but we can't see. So you did mention potential spooky customers. So maybe that's why it's not shared. So it's up to you if you want to share it. Just wanted to let you know.
I thought I was. Maybe I need to
there you
drag
go.
it over here. Okay, so what I did was I followed, so you didn't see my moves in. I went into the chat. I put the G Drive repository into the chat. Here, I'll do it again. The G Drive repository takes you to, let's say, you can see the sensor test lane with high hovers, and I just selected on the first video.
Okay.
If you go to the second one, you get the thermal bad guy. Although this is not a bad guy, he's a good guy. He's just acting like a bad guy. To have him run by our sensor targets at the same idea, 300 feet.
Mm-hmm.
But what I wanted to show you was maybe what the sensor test lane looks like. So let me just let this play. So all this is available to you online. If you just click through the G Drive is an ever-growing repository. So I'm trying to keep it organized. It's organized by test lane. And if you have an interest in a test lane, then you probably will find what you need there. So when you're looking for simulation support, you got to look in the open test lane. That's where simulation support is. If you're interested in high hovers, look in sensors.
Yeah. Our claim to fame is carrying heavier payloads. So running the ScanEagle level type sensors that are multispectral. And the Dream systems, 80 footers running MX-15, the same balls they run on the full size. But we can play in the sUAS market because we're it's an airship. So you can go, we're more flexible on altitude than the larger fixed wings. Larger aircraft that can carry these payloads. So that's why I'm really interested to see how well we do on something like this, say at 1,000 feet or 2,000 feet.
Yeah, well, you know, the reason why these posters are 4-foot posters is because we started with fixed wing that were flying up to 400 feet, and they couldn't see squat when we started, like literally. So we had to make these oversized charts. Now they still are in play for a lot of systems, but you know, you can also, these are posters with multiple targets on them. Those are the size of the bucket stickers. So you can make your own if you have the bucket stickers. You don't have to pay for the vinyl.
Well, the main thing is doing it in partnership with somebody, with NIST or one of your events. That way, it's not really accredited. It's just someone that we did it with. And that way, when you go to CBP, Border, Coast Guard, we ran through this and here's how well we did. That's
so do you say you're in Texas?
Yes.
Do you know Reveille Peak Ranch?
I just got a couple of messages. I got Mark Hill, who's a NEST guy in my area, looks like. And we got AVSI North. We got a bunch of, I think we have some NEST people around here. We won't be ready to fly for probably 6 to 8 months. So it's enough time to get to know everybody and try to find a good place to go.
Well, so my one-stop shopping in Texas is Reveille Peak Ranch.
Okay.
Tom Prentice is the leader there, and he travels the state with these tests for his responder community. So, but he's got a home court there that would be an excellent proving ground for you when you're ready.
Sounds great. Thanks, guys.
Thank you. All right, so let me take a look and see if anyone has any questions. Otherwise, we're gonna end this recording, and you guys can be looking for an email from myself or Adam later on with some links. Want to thank everyone for their time. Really, this is important to us to be able to just share with you. The fact that we're not reinventing the wheel. We're trying to help be proficient amongst ourselves and just be safe operators. So again, nothing is replacing the authority of the FAA. I am a volunteer safety team rep. With the blessing of the FAA, we were allowed to present this to you. So thank you to them, and thank you to you all, and most of all, thank you to Adam and the NIST team. You all take care. Enjoy the rest of your day.
Thanks, Dave.